All right, in this video, we're going to do the follow-up video for the second part of deriving the unit circle. In the first part, we talked about angles that are related to 45 degrees. In this video, we're going to talk about angles that are associated with 30 and 60 degrees. So to start off, I'm going to draw my unit circle. There's my unit circle. Here's my y-axis, and here's my x-axis. So this is my origin right here. Right, so the angle that we looked at previously was the 45-degree angle. That was this angle here. Now we're going to look at 30 degrees. I'm going to use a different color for that. I'm going to use red. So here's my 30 degrees right here. So I want to look for this ordered pair that's sitting on the circle when I sweep out 30 degrees. So the trick is I'm going to drop down and create a 90-degree angle here, which means this angle here would have to be 60 degrees because the total angles in that triangle should be 180. Now, if I draw a reflection of that triangle on the other side, so here's 90 degrees, this would be 30 degrees, so that means this would have to be 60. Here's my trick. If I pull that triangle out and I look at this separately, here's the red top part, here's the blue. Sorry, I'm not very good at drawing pictures here. Now, if I look at this 30 degrees here plus this 30 degrees here, this whole thing would be 60 degrees. We already said that right here is 60 degrees, and right here is 60 degrees. So what I have here is an equilateral triangle. So this whole thing here to here to here is an equilateral triangle, which means not only are the angles the same, but the sides have to be the same as well. And since I know that this is a radius of 1, so this side right here is 1. This has a radius of 1, so this side right here is 1. Then this side here also has to be 1. So I have all the sides are equal to 1. Now, if I call, let me use a different color here. If I call this side X, that's associated with this X here. And if I call this side Y, that's associated with this coordinate here, Y. Here's X, here's Y. So this whole side here is equal to 1, which means half the side, which is equal to my Y, has to be a half. So I have Y is equal to 1/2. So I know what my Y coordinate is. It's 1/2. So now I can use Pythagorean theorem to finish this off to figure out what X is. If I look at just half this equilateral triangle, this part right here, there's my X, there's my Y, here's my hypotenuse. So I can use Pythagorean theorem. X squared plus Y squared is equal to 1 squared, which is 1. I know that Y is a half. We just figured that out. So I'm going to put in X squared plus 1/2 squared is equal to 1. So I have X squared plus 1/4 is equal to 1. Now when I subtract 1/4 from each side, I get X squared is equal to 3/4, because I can change that 1 into 4/4, and when I subtract 1/4, that gives me 3/4. Now to finish solving this for X, I have to square root both sides. So I get X is equal to plus or minus the square root of 3/4. I can take the square root of 4, and I get plus or minus the square root of 3/2. Now, because we're talking about the first quadrant, I know X should be positive, so I'm going to make this positive square root of 3/2. Now, if I find that same point over here on the unit circle, that's going to be the same ordered pair, but with sign changes. When I'm in the second quadrant, the X should be negative, so I should have minus the square root of 3/2 and positive 1/2. So that's going to be 180 minus 30. So that's going to be 150 degrees here. So I swing open to 150 degrees. If I go to this point down here, that's going to be minus the square root of 3 over 2 minus 1/2. That's 180 plus 30, because this is another 30 degrees. So that's 210 degrees if I swing all the way open to 210 degrees. Now, the same point over here is going to be positive square root of 3 over 2 and minus 1/2. Okay, that's going to be 330 degrees. If I come all the way out and swing open, that's 330 degrees. That would be this point right here. Now, looking at all the 60-degree angles now, all I have to do is make a small tweak. If this is my unit circle, so now we have talked about 45 degrees. Here was my 30 degrees, so this was the square root of 3 over 2, 1/2. Here's my 45 degrees. That was the square root of 2 over 2, square root of 2 over 2. Now I want to swing open to 60 degrees to find this point right here. The trick to that is pretty much the same argument we just made for 30 degrees, but we're going to switch our triangle. So if I make my triangle like this, where I make my two triangles side by side, so this is 1/2, this is 1/2 for a total of 1. This is 1 here, and this is 1 here. These are all 60-degree triangles, or 60-degree angles. This point right here, making the same exact argument we just did, just turning the triangle in a different way, this would be 1/2 square root of 3 over 2. That means this point over here would be minus 1/2 square root of 3 over 2. This point down here would be minus 1/2 minus the square root of 3 over 2. This point right here would be positive 1/2 minus the square root of 3 over 2. And now we found all the points on the unit circle for the major angles that are relevant to 45 degrees or related to 45 degrees, 30 degrees, and 60 degrees.